So I'm going to talk about logarithms and exponentials and their relationship. First of all, let's look into why we care about this stuff. In the past, we might have looked at an equation like this: 3x plus 2 equals 5. And we might have said to ourselves, well, geez, I'd like to be able to solve for x. I'd like to know what value of x makes this a true statement. And then we looked at all kinds of other interesting functions, and we figured out new and interesting ways to solve for x with them as well. And it turns out with exponentials, this is no different. For example, we might like to solve a problem that looks like this. 2 to the power of x equals 8. You'll notice that this is a little bit different from some of the other functions that we looked at where we tried to solve for x. Here, the x is the exponent. Usually the x is not the exponent. So when the x is the exponent, we call this an exponential equation. In this particular case, we're lucky because we have 2 to the power of x, and we know that 8 is some power of 2. So for example, we could say, well, 2 to the power of x will repeat, and then 8 could be rewritten as 2 to the power of 3. And then it turns out that there's a property of equality for exponentials that says that if the bases are the same and they're set equal to each other, then we can assume that the exponents are equal as well. So in this particular case, we can just say, okay, x equals 3. So that doesn't seem too difficult. However, there are cases where it's not entirely obvious, and for that we might need some extra new tools. So let's take a look at one such case. What if we had something like 2 to the power of x equals 7? Well, in this particular case, it is not entirely obvious what power of x gets us 7. So we're going to do something else. We're going to convert this exponential equation into a form known as a logarithm. And the way we do that is, well, first of all, I'll go ahead and I'll begin to show you what a log looks like. Here's the word log, and then usually a log has a base, and since this exponential has a base, we'll just go ahead and we'll copy that base on over. And then with logarithms, there's a sort of a technique that's required for converting, and I call this technique doing the snail. I didn't make that up, but a friend of mine told me about that, and I've adapted it. I like it. So what happens is we say log base 2 of the number 7, because we start with 2 and then we go to the number 7, is equal to x. And if we rewrite the equation in this way, you can see essentially we solve for x. So yay, that was pretty cool. Now the only trick is that maybe we just don't understand exactly what this log thing is. However, we're going to go through some exercises and get a better feeling for what logs are. But I just wanted to show you right off the bat why we care about logarithms and also their relationship to exponential equations. Essentially, logarithms and exponential equations are inverses of one another, and that's something that we've talked about in the past. So let's take a look and try to get a feel for what logarithms are. And we'll do that by converting back and forth between logarithmic form and exponential form. So let's take an example of something that we're pretty familiar with. We know that 5 squared equals 25. We've been working with that for a long time in our career as math students. So what I'm going to do now is I'm going to rewrite this as a logarithm. And again, to rewrite an exponential as a log, we'll use this sort of snail procedure, do the snail. We'll say that we start at 5, go to 25, and then go to 2. So I know that with a log, I'm going to start with the little number down here, that's the base, and in this case, the base of the exponential is 5. So I'm going to go ahead and write like such. And then the snail tells us the next number we'll write is the 25. And by the way, the name of the 25, the official name here, it's called the argument, if you want to add that to your notes. So in the future, that's something we'll talk about. That guy has a name. Probably useful to make note of. And then The next thing is we'll write an equal sign, and then finally we'll follow the snail arrow, and that takes us to the 2, so this is then equal to 2. So the process is just sort of follow the arrows of the snail and then write the numbers for the logarithm. So, and by the way we say this is log base 5 of 25 equals 2. I would love it if you would pause this video right now for a moment and say that to yourself a few times. Log base 5 of 25 equals 2. The more ways that you can think of to understand this material, to get to know the material, the better off you'll be. Okay, hopefully you're well versed in how to say this now. Let's try a few more examples. So we'll try a few more things that we should know. For instance, 4 to the power of 3. What does that equal? Come on, quick, quick. You should know this. 64. And then we'll rewrite that as a log. And again, log base 4, because we start off with the base. And then the next thing we do, if we're doing the snail, we then go to the 64. And we're not entirely sure why we're writing it here right now, but yeah, as we get more practice, we'll get it. And then we go on to the 3, and that goes after the equal sign. And so there we go. Now we've converted from exponential form to logarithmic form. These two statements are equivalent to one another. They're just different ways of writing the same thing. And in fact, just to show you, just to remind you of stuff we've seen like this in the past, when we looked at this, y equals x squared, we were able to swap the x and the y and then solve for y. And when we did, we ended up getting we ended up getting y equals plus or minus square root of x. So, and that, I like this better. I decided to find the inverse of this and not swap the x and the y's. Now, this is a better example of how this thing that we did before is related to this new thing that we're doing now. Essentially, this and this are two different ways of writing the exact same thing. These two statements are equivalent to one another. Here, I just got x all by itself. I solved for x. And over here I solve for y. But same exact statement. That's what we're doing with logs. All right, let's try another one with logs. Let's see, maybe you might even pause the video and try to do this on your own. Let's see what you can do with this. I want to get a little fancy this time. What if we try something like, how about 25 to the 1/2 power? Do you remember what that equals? Why don't you pause the video for a moment and see if you can do it. Don't use a calculator. See if you can remember it. All right, hopefully you got the same thing that I'm about to write, and that is the number 5. Now again, this is just an exponential equation, and it can be rewritten as a log. So I'll go ahead and I'll write it as log base 25, as strange as that seems, of 5 equals 1/2. Now, there's something that I'd like to point out at this moment, is this. I want you to notice that this 1/2 is the exponent in our exponential equation. And what that means is that this log base 25 of 5 is actually an exponent. Log base 25 of 5 is an exponent. And in fact, the exponent that it is the exponent of 25 that gets us 5. That's important. If you can visualize logs in that way, you're well on your way to being very successful with this chapter. Okay, so now that we've had some practice of converting exponentials to logarithms, let's do the other way around. So I'm going to go ahead and write a logarithm, and we'll say log base 2 of 8 and we'll say that equals 3. And then I'm just going to go ahead and rewrite this. And again, I'm going to use the sort of snail technique. I'm going to say that 2 goes to the 3 and 3 goes to the 8. And then what we do is, remember this little guy here is the base of the log, and exponentials have a base that's kind of big. And then we'll say 2 to the power of 3, and then we'll say equals 8. So if I just kind of follow this path, it's 2, then 3, then 8. 2, then 3, then equals, then 8. So there we go. So I just converted the log to exponential form. Let's try another one. Hopefully you're beginning to feel like me that this is kind of fun. It looks kind of complex, but once you get it, there's some cool stuff going on. I'm going to try something a little tricky this time. I'm going to say log base 9 of 3. And before I say anything more, I'm kind of wondering if you know what goes here next. Why don't you pause the video for a moment and see if you can figure it out? Okay, so I hope that what you came up with is 1/2. And for those of you who are not quite sure, how the heck did he come up with 1/2? Here's what I want to say to you. I want you to practice saying this, what I'm about to say. Is we start with the 9 and we say 9 to the power of 1/2 equals 3. Okay? 9 to the power of 1/2 equals 3. I'm going to write it out over here as an exponential so that you can see it. Again, it's 9 to the power of 1/2 equals 3. I'm just doing the snail, and as I do it, I'm writing out the exponential. But it's so important. If you could say these words, why don't you pause the video for a moment and say it a few times. 9 to the power of 1/2 equals 3. That's going to help you when this 1/2 is missing. It's going to help you figure out what you want to put here when you know this number and you know this number. All right, pause the video for a moment and say that a few times. All right, let's try another tricky log and see what you guys can do with this. So I'm going to say log base, let's do log base 4 of 1/16, equals. Now again, I want you to pause the video and take a minute and see if you can figure out what goes over here based on the exercise we just did there. Go ahead and pause the video. All right, I am so hoping that what you decided on over here was -2. Yeah, because if I take 4 and I raise it to the power of -2, I get 1/16. Yeah. And again, we'll convert to exponential form, so that's 4 to the -2 is equal to 1/16. Again, I'm just doing the snail here, just doing the snail, converting from 4 to the power of -2 equals 1/16. There you go. All right, now I'm hoping that you guys are beginning to get a little bit of a feel for this, and so we're going to try something else sort of interesting after this. All right, now that you're coming up to speed on logarithms, we're going to try something really cool. Your calculator can compute a log, but so can your brain, and sometimes your brain can do it even better than a calculator. So I'm going to give you a log, and we're going to see if you can figure out what the value of this log is. So I'm going to say log base 3 of 81. And you got to tell me what that's equal to. What is that? What is the value of log base 3 of 81? Pause the video for a moment if you have to think about it. All right, here's what I'm hoping that you did. I'm hoping that you said to yourself, well, if I put an equal sign here and I just made a box over here where I wanted to put something for later, I could say, well, 3 to whatever 3 to the power of whatever this is should equal 81. So essentially what we're saying is we're kind of saying 3 to the power of x equals 81. That's sort of what we're doing here. And I would prefer to avoid this step. It'd be really nice if you guys knew your powers well enough to just do this. But this might be a step that might help some people. Anyways, hopefully you came up with the number 4. It turns out that if log base 3 of 81 equals 4, then log base 3 of 81 must be 4. Okay, I mean, I'm being redundant, but that's the case. So the value of log base 3 of 81 is 4 because 3 to the power of 4 gets us 81. All right, let's try a couple more and see how you do. All right, I'm hoping this is an easy one. Why don't you try to evaluate, find the value for log base 5 of 125. And by the way, when you're doing these things, say to yourself what I'm saying. Say log base 5 of 125. Using the language can help you to better understand what you're doing here. You go ahead and pause the video, and in a minute we'll catch up. Okay, hopefully you agree with me that the value of this is 3, because 5 to the power of 3 is 125. Let's try one that's a little bit trickier. How about this? Let's try log base, I'm going to try log base 64 of 2. That one's going to require a little bit of thought on your part. Let's see what you folks can come up with. All right, hopefully you paused the video. If not, pause it now and take a moment. I'm going to go ahead and explain what the deal is here. Essentially, 64 is 2 to some power. 32 is 2 to the power of 5. This must be 2 to the power of 6. So we got to say 2 to the power of 6 to what power gets us 2? And so therefore 2 to the power of 6 we're saying to what power gets us 2 to the power of essentially 1. This guy right here is 2 to the power of 1. So, well, it's 2 to the 6x equals 2 to the 1. So essentially what we're saying is 6x must equal 1. And therefore, as a result, this guy must be the power of 1/6. If you figured that out, you're doing pretty well. That was kind of tricky. I'll give you one that's a little, this will be more of a medium challenge. Let's try, how about log of, let's try log of 81, log base 81 of 9. Let's see what you can do with that. Again, hopefully you put the thing on pause, and this is what you should have gotten. It would be 1/2. 81 to the power of 1/2 gets us 9. And there was one more that I wanted to throw in, so let's go ahead and try this one more. How about log base, let's try 3 over 1 over 9. There we go. Log base 3 of 1 over 9. See if you can evaluate this. Take a moment, hit pause, take a moment, think about it. Okay, I am hopeful that you came to the conclusion that this is going to be a -2. 3 to the power of -2 is 1 over 9. So again, that would be the value of log base 3 of 1 over 9. Because remember, logarithms are just exponents. The logarithms, the whole logarithm, including the argument and the base, is the exponent of the base that gets us the argument. That's what logarithms are. And if that's helpful to you, pause, hit rewind, play again, and write that down. That's how you learn, folks. All right, let's talk about one last topic for this video, and this will be solving equations. So what we're going to do is this. I'm going to go ahead and write out, let's write out a logarithm. And I'm going to do log base 3 of x equals, what the heck, let's try 15. Now, the thing here is this. Notice how that x is not isolated. It's inside the log function. It's the argument of the log function. So what we'd like to do is we'd like to isolate the x. Well, the way we do that is we convert from log form into exponential form. So let's go ahead and try it. We're going to do the snail. We're going to say 3 to the power of 15 equals x. 3 to the power of 15 equals x. Voila! What I want you to notice here, folks, is we did exactly what we were trying to accomplish. We solved for x. We solved for x by converting from log form to exponential form. Let's take a minute to write that down because that's so crucial. All right, people, I'm serious. Take a moment and write this down. We solved the logarithmic equation by converting to exponential form. That's huge. Okay, go ahead and hit pause and write that, and then I'm going to go ahead and continue here. Okay, so the next thing is let's try solving an exponential equation. So we're going to try something like, how about 7 to the power of x equals 2. Again, notice that the x is not isolated. It is the exponent, and therefore we don't know what its value is. And we certainly don't know to what power of 7 is 2. So what we'll do is we're going to convert this exponential to log form. And this is something that I actually alluded to at the beginning of this video. So this shouldn't come as a huge surprise to you. We're going to do the snail, convert to log form, and then see some magic in action. So we start off with log. And then we write the little base, which is 7, because the big base there is 7. And then the next thing we write, following the snail, we write 2. So log base 7 of 2 is equal to x. And again, I would so love it if right now you would take a moment and say what this says. Say log base 7 of 2 equals x. The more you get to know this stuff, the better off you'll be. And then celebrate, because we just isolated x. We freed x. We set it free from its prison, in its lofty prison in the exponential position. Now the x is all by itself, just like we wanted it to be. And all we got to do is figure out, well, what do we got to do to figure out what log base 7 of 2 is? Well, guess what? Later on we'll figure out a way to do that with our calculator. But for now, we should be really happy that we solved for x. And we did it by converting from exponential form to log form. Let's take a moment and write that down. I'm going to go ahead and write the text for you. All right, folks. So now we've had some practice in trying a few things. We've pronounced what we saw. We've written down the things that we said about what we saw. If you go through this video, you might even want to go through it a second time. You'll get a really good understanding for this stuff. Now, if you don't get overly confident though, because if you're saying to yourself, oh, I get this, this is easy, don't kid yourself. We've still got a lot more to do with logarithms and exponentials. This is just the beginning. If you get this, great, but we got to build off of it. So it's not just a matter of getting this. You need to nail this. You need to really understand this deeply. And if you do, then the next few stages that we go through will be tolerable. All right, folks, good job. We're done.